Hello everyone, welcome to Digital Learning BCE. Myself Dr. Yamini J, Assistant Professor of Mathematics, Government First Grade College. In this video, we are going to discuss about simultaneous linear differential equation with the constant coefficients in Differential Equation 2, BSc 4th Semester Mathematics. Simultaneous linear differential equations with the constant coefficients. We consider a method of solving a system of two simultaneous linear differential equations containing one independent variable, say t, and two dependent variables, say x and y. The method consisting in first reducing the system to a single second order equation for one of the dependent variables and solving it for that variable. The other dependent variable can be obtained by using one of the given equation. Throughout this session, we put capital D is equal to d by dt, t being a independent variable. The first problem is solve dx by dt plus 2y is equal to minus sin t and dy by dt minus 2x is equal to cos t. This is our given equations in the problem. So this is the second part of simultaneous equation we are doing. So you know how to rearrange the equation and write equation 1 and 2. Using the same concept we are writing the equation 1 is dx plus 2y is equal to minus sin t and second equation is minus 2x plus dy is equal to cos t. Now we are going to solve the equation 1 and 2, try to get the value x or the variable y. So now the equation 1 has to multiply by 2 and the equation 2 has to multiply by d. So equation 1 is multiplied by 2 means we'll get 2 into dx plus 4y is equal to minus 2 into sin t, and the equation 2 is multiplied by d means we'll get minus 2 dx plus d square y is equal to minus sin t, because d of cos t, the second equation having cos t in the right side. So we are multiplying with d means d of cos t. D into cos t means d by dt of cos t. That is, we have to differentiate with respect to t cos t. So that's why it become minus sin t. So we got this equation. Now we are going to add these two equations. If you add these two equations, x term will vanish. We'll get d square plus 4 into y is equal to minus 3 sin t. Now it is the form of f of d into y is equal to f of x. Now from that we are going to write the auxiliary equation is m square plus 4 is equal to 0. Then this implies m is equal to plus or minus 2i. So now we got the root for this equation is complex root. That is with a complex number with alpha is equal to 0 and beta is equal to 2. Therefore, the complementary function is a cos 2t plus b sin 2t we are getting. So next we are going to find out particular integral for this. So the pi is equal to 1 by d square plus 4 into minus 3 sin t. See that f of x is here sin ax form. So sin ax form or cos ax form is there. We have to use particular integral second type. So with that we know the replacement of d square is minus a square. So here this a sin t is there, so a value is 1. So replacing d square is equal to minus a square is equal to minus 1. So in the denominator, for instead of d square we are substituting minus 1. So the pi become 1 over minus 1 square plus 4 into minus sin t. That is minus 1 plus 4 is minus 3. We'll get plus 3 in the denominator. Then that both the numerator 3 and denominator 3 will cancel. We'll get only minus sin t for particular integral. Now that equation from the complementary function and the particular integral, we are going to write y value. Y is equal to cf plus pi. That is equal to a cos 2t plus b sin 2t minus sin t. So we got y value first from the equation, given equation. Now we have to take any one of the given equation. So substitute the y value in that and try to get the next variable, that is x value. Now from the equation 2 we have 2x is equal to dy minus cos t. So here we know the y value, we are going to substitute that. So before going to substitution of y, we are bringing the left side to also right side. So we'll get x is equal to 1 by 2 into dy minus cos t. So substitute the value of y in the right side, we'll get x is equal to 1 by 2 into d of a cos 2t plus b sin 2t minus sin t minus cos t. So it is d of the value function is there, means we have to differentiate with respect to t once. That's why that first term become a cos 2t is there. If you a is a constant value. If you differentiate cos 2t, we'll get minus 2 sin 2t. So the d of a cos 2t become now minus 2a sin 2t. Next b is a constant, then you have to differentiate sin 2t with respect to t. So we'll get 2 cos 2t. Then minus sin t is there, again we have to differentiate that, you will get cos t for that. So if you simplify all this value, we'll get x is equal to 1 by 2 minus 2a sin 2t plus 2b cos 2t minus 2 cos t. So we third term and fourth term both are cos t, that's why we are adding that 2 term. So we'll get my 2 cos t. So now if you take 2 common and cancel, means we'll get x value is minus a sin 2t plus b cos 2t minus cos t. So equation 4 gives the x value. So equation the expression 3 and 4 constitute the general solution of the given equation. The next problem is solve dx by dt minus 3x minus 6y is equal to t square and dy by dt plus dx by dt minus 3y is equal to 2t. So first substitute d by dt is equal to capital D and simplify the equation, means we can write d minus 3 into x minus 6y is equal to t square as a equation 1, and the second equation become dx plus d minus 3 into y is equal to e to the power t. Consider that is equation 2. Now solving these two equations, we have to get x value or y value first. So now we are going for multiply equation 1 by d and equation 2 by d minus 3. So now the equation 1 has to multiply by d, means we'll get d into d minus 3 into x minus 6d into y is equal to d of t square. Then second equation is multiplied by d minus 3, means we'll get d into d minus 3 into x plus d minus 3 into d minus 3 into y is equal to d minus 3 into e to the power t. So now we have to simplify the above equations. We'll get d into d minus 3 into x minus 6dy is equal to differentiation of t square is 2t. That's why d of t square is equal to 2t we wrote in the right side. Similarly for the next one, d into d minus 3 into x plus d minus 3 into d minus 3 into y is equal to 2 into, we are having d minus 3 into e to the power t. d minus 3 into e to the power t means we'll get differentiation of e to the power t is e to the power t, then minus 3 into e to the power t. So if you simplify that two equations, we'll get minus 2 into e to the power t. So now we are going to solve these two equations by subtraction. So if you subtract these two equations, we'll get d minus 3 into d minus 3 into y plus 6dy is equal to minus 2 into e to the power t minus 2t. So now if you have simplified this, we'll get d square plus 9 into y is equal to minus 2 into e to the power t minus 2t. So from that the auxiliary equation is m square plus 9 is equal to 0. Then m square is equal to minus 9, m is equal to plus or minus 3i. Again we got the complex root for this problem. So now complex root with alpha is equal to 0 and beta is equal to 3 means we have complementary function as a cos 3t plus b sin 3t. So now after finding the complementary function, as usual we have to go for particular integral for this equation. So the particular integral pi is equal to 1 by d square plus 9 into minus 2 into e to the power t minus 2t. So here we have two terms, that's why we are going to take separately. So multiply by that f 1 by f of t with both the terms. So we'll get minus 2 into 1 over d square plus 9 into e to the power t minus 2 into 1 over d square plus 9 into t we have. So the first term is e to the power at for ax form is there. So the second one is polynomial equation. So we have to use particular integral type 1 as well as particular integral type 3. For the first term type 1, for the second term we are using type 3. So first term become minus 2 by 10 into e to the power t. Here e to the power t means a value is 1. So in the first type we will replace d by a. So we are getting here d square. If you substitute d square value is 1, we will get the denominator is 10. So that's why we are writing minus 2 by 10 into e to the power t. So that become minus 1 by 5 into e to the power t. So the first term simplification is over. Now we are going for the second term. The second term is 2 into 1 over d square plus 9 into t means it is third type of particular integral, that is polynomial function we have. So polynomial functions are there means we have to use binomial expansion. Either we have to use 1 plus x whole to the power minus 1 formula or 1 minus x whole to the power minus 1 formula. So here both the terms are positive, that's why we are trying to make 1 in the place of 9. So we can take 9 as a common value. So in the denominator we will get 9 into 1 plus d square by 9 into t. So now 2 by 9, the second term only I am explaining now, minus 2 by 9 into that 1 plus d square by 9 as will go to the numerator, it become 1 plus d square by 9 whole to the power minus 1 we have into t. So now we got 1 plus x whole to the power minus 1 form. If 1 plus x whole to the power minus 1, expansion is 1 minus x plus x square minus x cube plus etc. It's going on. So here in the place of x we have d square by 9. That's why the second term become now minus 2 by 9 into 1 minus d square by 9 plus d to the power 4 by 81 plus etc. into t. Now t has to multiply inside. So the second term become 2 minus 2 by 9, 1 into t is t, then second term is d square by 9 is there. D square means we have to differentiate the function 2 times, but what is our function here? Only t is there, maximum we can differentiate 1 time. If you differentiate first time, t become 1. If you are going for the second time, differentiation becomes 0. So d square by 9 into t becomes 0 here. So similarly the third term also 0. So only we are getting minus 2 by 9 into t for the second term. So using the particular integral type 1 and type 3, we are solving the first term as well as third term. Therefore y is equal to complementary function plus particular integral. So y is equal to a cos 3t plus b sin 3t minus 1 by 5 e to the power t minus 2 by 9 into t. So consider this is equation 3. So after finding the y value, we have to substitute this y value any one of the given equation and trying to get the x value. So from the equation 2, we can write here dx is equal to e to the power t minus d minus 3 into y. So we are going to substitute the y value in this equation. So we'll get dx is equal to e to the power t into d minus 3 into a cos 3t plus b sin 3t minus 1 by 5 e to the power t minus 2 by 9 into t. See here we have to multiply the whole y value with d as well as with the 3. So that's why we are splitting now. In the next step we are multiplying separately and writing e to the power t minus d into the y value plus 3 into that y value. Now d is there means we have to differentiate the function once with respect to t. That only we are going to do in the next step. So dx is equal to e to the power t minus, if you differentiate the a cos 3t, a is a constant If you differentiate cos 3t, we will get minus 3 sin 3t. So the next one is b sin 3t is there. B is a constant, so sin 3t differentiation with respect to t means 3 cos 3t we have. That's why we have 3b cos 3t here. Then minus 1 by 5 e to the power t is e to the power t only. Then the last term is 2 by 9 into t is there. So if you differentiate that with respect to t means we'll get 2 by 9 into 1. That is 2 by 9. So then 3 into means just multiply 3 inside with the y, we'll get 3y values. So now dx is equal to e to the power t plus 3a sin 3t minus 3b cos 3t plus 5 by 1 by 5 e to the power t plus 2 by 9 plus 3a cos 3t plus 3b sin 3t minus 3 by 5 e to the power t minus 2 by 3t. See here we have many variety of terms, that's why we are going to combine that. So e to the power t we can take it separate, then sin term we can take it separate, cos term we can take it separate. That's why we are going to simplify based on that. So if you sin term and cos term if you combine together, we'll get dx is equal to e to the power t plus 3a plus 3b into sin 3t plus 3a minus 3b into cos 3t plus 1 by 5 e to the power t plus 2 by 9 minus 3 by 5 e to the power t minus 2 by 3 into t. Again we are going for the further simplification means we'll get dx is equal to e to the power t plus 3a plus 3b sin 3t plus 3a minus 3b into cos 3t plus 2 by 9 minus 2 by 5 e to the power t minus 2 by 3 into t. See here dx value we got. Now we are going to find out x value. X value means we have to bring the d value to right side, it will come to the denominator. If it is in the denominator d value, we know we have to integrate the function. Here first function is e to the power t, so e to the power t integration is e to the power t only. Then second function integration is sin 3t is there, so integration of sin 3t is minus cos 3t by 3. Then third term is cos 3t is there, so integration of cos 3t is sin 3t by 3 plus 2 by 9 is a constant, so if you integrate with respect to t we will get 2 by 9 into t minus 2 by 5 into e to the power t, the integration is e to the power t. So we are getting the last term is minus 2 by 3, integration of t is t square by 2. If you are simplifying again and taking the common value as 3, we'll get what is the value we'll get, it is a plus b into minus cos 3t, 3 will cancel. Then similarly next term also 3 will cancel, so we are getting a minus b into sin 3t plus 2 by 9 t plus 3 by 5 e to the power t minus t square by 3. So we are taking the LCM and simplifying here. So the finally x value is a minus b into sin 3t and minus a plus b of cos 3t plus 2 by 9t plus 3 by 5 into e to the power t minus t square by 3. So this is the x value we have. So already we have y value. These two values are constitute the general solution of the given equations. Then the next problem is solve dx by dt minus 2y is equal to cos 2t and dy by dt plus 2x is equal to sin 2t. See here we are rearranging the equation, given equation with help of capital D and writing dx minus 2y is equal to cos 2t and 2x plus dy is equal to sin 2t. Consider the first one is equation 1 and second one is equation 2. Now the multiply equation 1 by d and equation 2 by 2 will get d square x minus 2 into d into y is equal to d of cos 2t. That means differentiation of cos 2t is minus 2 sin 2t. Then the second equation has to multiply with 2. That's why we are getting 4x plus 2 dy is equal to 2 sin 2t. So solving these two equations, that means we have to add these two equations, that's all. If you add, that y term will vanish, we will get only x term, that is d square plus 4 into x is equal to 0. So we have a auxiliary equation from this, that is m square plus 4 is equal to 0. Then m is equal to plus or minus 2i we have. So here the equation d square plus 4 into x is equal to 0 we are getting, because minus 2 sine 2t plus 2 sine 2t will cancel, will get 0 on the right side. If it is 0 on the right side, only the complementary function we have to find out, that itself is a x value here. So therefore x is equal to the complementary function of complementary function of complex root, that is complex root with alpha is equal to 0 and beta is equal to 2 is a cos 2t plus b sin 2t. Therefore x is equal to, we got a cos 2t plus b sin 2t. Now after finding the x value, we have to substitute this x value in any one of the given equation and try to get the y value. So now from the equation 1 we have 2y is equal to dx minus cos 2t. So dx minus cos 2t means in that x value we are going to substitute, that is d into a cos 2t plus b sin 2t minus cos 2t. So d into the function, d into that function means we know d is equal to d by dt. So we have to differentiate with respect to t once. So a is a constant, you keep it as it is, cos 2t into differentiation is minus 2 sin 2t. That's why the first term become minus 2a sin 2t plus b is a constant, we keep it as it is, sin 2t differentiation is 2 cos 2t. So that's why we got the second term is 2b into cos 2t. Then third term is as it is, we have to write, because no d term along with that, so cos 2t only we got. If you simplify this, we have y is equal to 2y is equal to this value. So that's why we are dividing by 2, we will get y. So therefore y is equal to minus a sin 2t plus b cos 2t minus 1 by 2 cos 2t. So here we have 2 cos 2t terms, that's why we are combining that too. So y is equal to minus a sin 2t plus b minus 1 by 2 into cos 2t. So this is our y value. Already we have x value. These two values gives the general solution of the given equation. Then next problem is solve dx by dt plus 2x minus 3y is equal to 5t and dy by dt minus 3x plus 2y is equal to 2 into e to the power t. So then we have to rearrange this equation with the help of capital D. We know capital D is d by dt. So the equation 1 becomes d plus 2 into x minus 3y is equal to 5t. Consider this is equation 1. Then the second equation become minus 3x plus d plus 2 into y is equal to 2 into e to the power 2t. So we got equation 1 and 2. Now we are going for simplification. Multiply equation 1 by d plus 2 and equation 2 by 3 we get. See, we have to observe this equation and decide what we have to multiply with these equations. So if we are multiplying some value means that value has to vanish. Like that we have to check. Now if we are going with the first equation multiply by d plus 2 means that equation become d plus 2 into d plus 2 into x minus 3 into d plus 2 into y is equal to, here we have to differ 5t is there on the right side. So 5t has to multiply with d plus 2. So if you are multiplying d plus 2 with 5t means we will get d plus 2 into 5t. If you multiply 5t inside, we will get d of 5t. d of 5t means we have to differentiate 5t with respect to t. So if you differentiate 5t with respect to t means we will get only 5. T become 1. Then 2 into 5t is 10t. That's why the right side value become 5 plus 10t. Then the second equation is multiplied by 3 means we will get minus 9x plus 3 into d plus 2 into y is equal to 3 into 2 is 6. 6 into e to the power 2t we have. So now seeing this equation only, you come to know which variable is going to vanish. So we can adding these two equation means y variable will vanish, we'll get the x value. So we are going for that simplification by addition. So by addition we have d square plus 4d plus 4 minus 9 into x is equal to 5 plus 10t plus 6 into e to the power 2t. Right side value also we have to add it here. Now the equation become d square plus 4d minus 5 into x is equal to 5 into 1 plus 2t plus 6 into e to the power 2t we have. So now from this we are going for auxiliary equation first. From that we can find out complementary function, then we can go for particular integral. So here the auxiliary equation is m square plus 4m minus 5 is equal to 0. With the factorization we get m value is 1 and minus 5. So m is 1 and m1 is 1 and m2 is minus 5. Both the values are real and it is distinct. That's why complementary function is c1 into e to the power t plus c2 into e to the power minus 5t. Now we can find out particular integral. So the particular integral pi is equal to 1 by f of d. So here f of d is d square plus 4d minus 5. That's why we got 1 over d square plus 4d minus 5 into 5 into 1 plus 2t plus 6 into e to the power 2t. See here we have three terms for f of t. So 3 terms are there means, 2 terms are there here for f of t. So we have to split it there. Two kinds of functions we have. One is exponential function, another one is polynomial function. So we are going to make it separate, that 2 term. So that's why we got 1 over d square plus 4d minus 5 into 5 into 1 plus 2t. First term. The second term is 1 by d square plus 4d minus 5 into 6 into e to the power 2t. So the first term we have to simplify with type 3 of particular integral, and for second term has to simplify with the first type of particular integral. So the first I will explain the first term, then we'll go for the second term. See, in the denominator we have d square plus 4d minus 5. If it is a polynomial function means we have to use binomial expansion, you know that one. Binomial expansion 1 plus x whole to the power minus 1 form, or 1 minus x whole to the power minus 1 form we have to get. That's why I am taking 5 minus 5 as a common value in the denominator. So 1 over minus 5 into 1 minus of d square plus 4d by 5 will get in the denominator into 5 into 1 plus 2t. So if you are going for numerator to denominator, so what will happen, that 5 will cancel here, then minus will be remaining the same. So minus of 1 minus d square plus 4d by 5 whole to the power minus 1 into 1 plus 2t. So now we got the form of binomial expansion form of 1 minus x whole to the power minus 1. So the binomial expansion for that is 1 plus x square plus x cube plus x to the power 4 plus etc. It's going on. So here our x value is d square plus 4d by 5. That's why we got minus of 1 plus d square plus 4d by 5 into, plus etc. It's going on into 1 plus 2d. So now second term, third term onwards we will get whole to the power 4, d to the power 4, d to the power d square and all. We don't want that value. That's why we are taking only first and second term. So why we don't want means our function is 1 plus 2t. 1 plus 2t if you can differentiate maximum 2 times. Third time onwards it's become, maximum 1 time. If the second term onwards it's become 0. That's why d square also we don't want. So we are consider only first term and second term here. Minus is outside. 1 into 1 plus 2t we are going first. Multiply with inside value means 1 plus 2t will get first one. Then d square by 5 into 1 plus 2t becomes 0. Because d square means we have to differentiate 2 times that function. So it becomes 0. That's why we are not writing that term. Then next one is 4 by 5 into d into 1 plus 2t. 4 by 5 we have to keep it as it is, d into 1 plus 2t. d into 1 plus 2t means we have to differentiate 1 plus 2t with respect to t once. So we'll get 0 plus 2 into 1, that is 2. So 4 by 5 into 2 we got. Then we have to simplify this term. So we'll get minus 1 minus 2t minus 8 by 5 we got for the first term. Now we'll go for second term of the simplification. So second term from beginning I will explain. So what is there in the second term? 1 over d square plus 4d minus 5 into 6 into e to the power 2t. So this is the first type of particular integral, e to the power ax form. So here we know what we have to do, how to simplify this by replacing d square is equal to by replacing d is equal to a is equal to 2. So substitute d value is 2 in the denominator. We'll get what we'll get, d square means 4 plus 4 into 2 is 8 minus 5. So we'll get 6 by 7 into e to the power 2t will get. So a very simple simplification, only replace d by 2, that's all. 4 plus 4 minus 5. So we'll get 4 plus 4 into 2 is 8. So 4 plus 4 into 2 minus 5 means we'll get the denominator value is 7. So 6 by 7 into e to the power 2t we have. So we have now pi is equal to minus 2t minus 13 by 5 plus 6 by 7 into e to the power 2t. So after simplification we got it like this. Now the x value is complementary function plus particular integral. So complementary function is already we found out. So x is equal to c1 into e to the power t plus c2 into e to the power minus 5t plus 6 by 7 e to the power 2t minus 2t minus 13 by 5 we got for x. Now we are going to substitute this value in any one of the given equation and we are going to find out the y value. So from the equation 1 we have 3y is equal to dx plus 2x minus 5t. So substitute the x value here, d into x value, whatever we found already, plus 2 into x value minus 5t. Now d means we have to differentiate with respect to t once. That's why we are differentiating the terms. All the terms we have to differentiate once. Inside the bracket value we have to differentiate. So first term is c1 into e to the power t. So c1 is constant, e to the power t differentiation is e to the power t only. So that's why we got first term is c1 into e to the power t. If you go for the second term, c2 is a constant, e to the power 5t differentiation is minus 5 into e to the power minus 5t. That's why the second term become minus 5 into c2 into e to the power minus 5t plus we are going for third term now. Third term is 6 by 7 into e to the power 2t. So in that 6 by 7 is a constant. We have to keep it as it is. E to the power 2t if you differentiate we'll get 2 into e to the power 2t. That's why we got 12 by 7 into e to the power 2t. Then minus differentiation of 2t is 2. That's why we got only 2 in the next term. Then the last term is minus 13 by 5. It's a constant term, so differentiation of constant is 0. So we are getting the d of x is like this. Now we have to take the second term. Second term is 2 into x. 2 into x means just multiply 2 inside, we will get some value. Then the third term is minus 5t. So now we are going to simplify all these values. In all this value, we are going to combine c1 separately, c2 separately, and e to the power 2t, t terms and constant term. So we'll get 3 into c1 into e to the power t minus 3 into c2 into e to the power minus t plus 24 by 7 into e to the power 2t minus 90 minus 36 by 5. So if you take 3 common, we'll get 3 into c1 e to the power t minus C2 e to the power minus 5t plus 8 by 7 e to the power 2t minus 3t minus 12 by 5. This is our y value. Because if you take 3, both the side 3 will cancel. We will get the y value is C1 e to the power t minus C2 e to the power minus 5t plus 8 by 7 e to the power 2t minus 3t minus 12 by 5. So this is our y value. Already we got x value. So these two values are constitute the general solution of the given equation. So from this example, I think you can understand how to solve the simultaneous equation with one independent variable and two dependent variables. Thank you for watching this video.